Well, good morning, everybody. Hope y'all are doing well. It's actually a little warm here today in Georgia. Imagine that. We've had some really good weather. 60s, low 70s for the past week or so, and now all of a sudden it's back up into the mid to high 80s, and it's a little warm in here. And of course you got to turn the fans and everything off for recording, so it is what it is. Got a simple job today, or I call it simple, but we've got a block of steel and an impact gun. So they don't have a whole lot in common, but the gentleman who wants me to do this, I'm trying to help him out. He's helping me out. So what he's doing is he's taking this block of steel and he's going to weld it onto a frame, run hold the hammer with it. It's got a set screw right here, and it'll be a plenishing hammer. So the kicker is he's got the block of steel, and it does have a hole in it, but this hole is, and this is just a rough estimate, so this hole's about 1 inch, 190 thousandths. And the shaft of this is 1 inch, 250 thousandths. So they won't fit together. So we need this to go all the way down and seat, kind of like that, so you can see the gun sticking out the other end. So I'm going to chuck it up in the 4-jaw chuck, take the set screw out of it, center it, and then we're going to bore this to 127 thousandths. That way there's a little room for the gun to go in and out without binding. So let's get started. Okay, so the first thing I've got to do is swap these jaws around. We have the narrow end down here in the center. The larger end of the jaw is out here, and that's what we need to hold the piece with. So you can hold it with this end, but you just don't have as much grip. So I'm switching it around so that we can hold the piece with that end. That'll give me a little more stability and make it a little more rigid while I'm working with it. And with this chuck, with it being a 4-jaw, all I do is rotate the jaws around and just crank the Acme screw out. It pulls the jaw out. I check it to make sure there's no debris that's actually got a chip in it. Make sure we're clear there. Put it in the reverse direction and then crank it back down. This works well with this type of chuck. In a 3-jaw, if you've got this kind of setup in a 3-jaw chuck, it's a little more difficult because you have to make sure to put them in the exact same spot, and you have to put them in a specific order. Otherwise, the synchronizing cam won't match up, and you'll end up, even though you think you're centered, you'll actually be off center, and everything you do, all the work you do in it will be off center. So much easier in a 4-jaw chuck to switch them around. All right, just like that, we've got them changed around. Now we're going to turn them in all about the same. There's indicator lines on the face of the chuck. And so I try to get them all roughly about the same location so that it makes centering the workpiece a little easier. All right. And I'm actually in a little too much, so we're going to back it out just a little. All right, let me get this done and then I'll bring you back. Okay, so I've got this kind of centered. I've got my dial indicator set up, and on this one, because this is a square, I can't center on the outside. I can, but it's a lot more work. With it having a hole in the center, it's a little easier. Even with the a little bit of rust in there, we'll run some sandpaper in there, clean that out. But we can run the dial indicator on the inside diameter, and it'll give us a lot better accuracy. So that's what we're gonna do. So right now I've got it zeroed. I'm gonna go on I've got it zeroed on this edge. We're gonna go on and rotate it and do the centering. I'm not gonna bore you with that because I did a video on it a while back. You can go look at it. I'll try to link it in if I can. But I'll bring you back when we get it centered up. All right, so now we've got it zeroed in. It's within a 1/1000, which should be good for this. Let me get the saddle out of the way and compound, and I'll show you what we're gonna do next. All right, so we've got to go up to 1 1/4 inches for the hammer to fit in it. I don't want to drill all the way up. You can see I've got the big taper shank drill bit in here. This is 1 inch and 7/32, which is 281. No, 200. Sorry, double check my chart. 218 thousandths. So quarter is 1 inch 200, or a 1/4 inch is 250 thousandths. So we'll be shy of that so that we can come in with a boring bar and do the final cut. But this will get us really, really close. So let me turn the rotary converter on. So we've drilled it to the 1 inch and 7/32. Now I'm going to use a T-gauge or a snap gauge to check the internal bore to see where we are with that. So I'm going to squeeze these ends, telescope out, so I'm going to squeeze them together. Just tighten it just a little. I'll put them inside. And let's see, get it in there. I tilted it at a slight angle. Then I tighten the end back and I rotate it. And that gives me the dimension on the inside of the bore. So now, if I can find my calipers, now we can take, if I wanted this to be really, really precise, I would use micrometers. This can have some play in it. So I'm just using the dial calipers, and I am showing 1 inch 225 thousandths. So I've got to take about 27 thousandths out of it still. We're going to do that with a boring bar. So we've got the boring bar set up. We cut the machine on. I'm just barely going to touch the inside edge, and we'll make a skim pass just to clean everything up. We'll check the diameter one more time, and then we'll dial in our final cuts. Okay. So now I'm at 1 inch, 247,000. I've got about 5,000 to go. But just to make sure all my measurements are right, I'm going to test fit and see it's still not going in. So we know we haven't overbored it yet. So I'm going to dial another 4 thousandths and we'll bore that and we'll test it. And then once we do that, we'll do everything else with a file or sandpaper to get the last thousandth and a half. Next thing we need to do is clean out any imperfections. With this being internal bore, I don't want to stick my finger down in there to try to do it, and I don't want to put anything really solid, like a file, because if it went in there, it could get away from you and break your arm or something. So I want to be careful with that. So I do things like this. This is just a plastic drill bit case. I wrap my sandpaper around it, turn the machine on, and let's check our width, our diameter. All right. We are right there. So, all right, so let's test fit our gun and see how it fits now. Oh yeah, there's a little bit, but not much. Okay, so now, all right, now that the hole's at the final bore size, we need to chamfer the hole. That gives it a little bit of a bevel so that whatever goes in it can go in easily and guide without getting hung up. So we use this tool. I've heard it called a pigtail, a widget, a deburring tool. It's known by a bunch of different names. So okay, I flipped it around to deburr this other side. If I was going to bore it again or drill it, I would want to center it. But because this is a handheld tool and all I'm doing is deburring or chamfering the edge of it, I don't have to recenter this. So, all right, so there it is. Fits good. The threaded tap or tapped screw hole didn't get damaged. Fits in real snug, so I think that'll work out good for him. This little project, all total, it took me about an hour because I was filming and setting things up, things like that. So if on a normal day, if I wasn't filming, 15 minutes, half an hour maybe. But I thought this might be something neat. I really appreciate all the subscribers. Thank y'all for being part of this. Thank y'all for following along, commenting, sharing. I really appreciate it. It grows the channel. It's helping me become a better public speaker, better creator, and it's also giving me a reason to get out here and get some work done other than the financial part of it. So thank y'all for following along. I hope you're doing well. Take care of yourself. Take care of your friends. God bless y'all. See you on the next one.